Hello fellow Scratchers, welcome back to part 4 in our series, Creating a Tile Scrolling Platformer in Scratch. In this episode we will bring Mario fully to life, fleshing out his platforming scripts, and giving him some awesome animations to boot. Just look at him go, this is really great, and to wrap up the episode we will improve Mario's collision box and sneak in a simple particle system to add to the skid effect. Wow, all this in one episode. Amazing. When I began creating this tutorial series, I didn't include the required Mario costumes that we are going to use in my starter project. That's no longer the case, but if you need them, then you'll find a link under this project to the updated Scratch resource, and I'll quickly talk you through how to get them into your existing project too. So, you can either click the Scratch project link under my video, or visit my Griffpatch tutor page directly and find the Mario resource project there. Look inside and, oh nice, look at all these lovely animated frames that I've lovingly cut out, positioned, ready to animate. All for you, you lucky people. Click your backpack bar to open it, and drag the entire Mario sprite onto it. Next, we'll also backpack this cute little particle sprite for later, and lastly, click on the stage backdrop. We might as well bag this single blue backdrop costume too. Okay. Now load up your tile scrolling platformer project from where we left off in episode 3. If you open your backpack once again and drag the entire Mario sprite out, dropping it safely in the sprites panel to the right. Do the same with the particle sprite, and then carefully drop the blue backdrop costume onto the stage backdrop panel, like this. Now we have 2 Mario sprites, so click into the Mario 2 sprite. That's the one we just dropped from our backpack. And switch to the Costumes tab. We will carefully drag each costume one by one from here to our main Mario sprite, like this. I like to count them off as I do it, one by one, to keep track of which costume I'm up to. You should find 9 of them. Lastly, click into your first Mario sprite and delete the costume Mario 1. If you have the dot costume like me, then delete that too. If all has gone well, then we should end up with 9 Mario costumes all ready to go. You are then free to delete this Mario 2 sprite if you like. I left mine in, but only because I was too excited to move on. And so, in the words of Mario himself, here we go! Okay, the first thing we're going to do is add some excellent Mario-style jumping code. Currently, in our project, we're able to jump to any height and engage the jump at any time. Perfect for a jetpack game, but plain rubbish for a platformer. We need to set some rules that Mario is only allowed to begin a jump when his feet have recently touched the ground. To do this, we'll make a new variable named falling for this sprite only. Locate the X and Y movement scripts here under the When I Receive Move Player event. We're going to split these out into their own custom blocks. So make with me a Move Sprite X block, run without screen refresh, and a Move Sprite Y block, again without screen refresh. Now move the Change Y and its Fix Collision block into the Move Sprite Y custom block, and do the same for the Move Sprite X. We'll then place the new Move Sprite X and Y blocks in place of where we switched out their scripts. You can test this if you like to ensure it works just as before. I want to make some space for these new blocks. If you have my Scratch DevTools browser extension installed, there's a link under the video, then using the Cleanup Blocks Plus feature will helpfully move these other scripts over to the right. But otherwise, you're best off moving them by hand, I'm afraid, that Scratch's built-in cleanup feature is rather brutal. Add a change falling by 1 after the change Y by speed. This way, the falling variable will be continually counting upwards. But what if the player isn't falling? Well, we should then be setting this back to 0 when we touch the ground. We detect ground collisions here within the Fix Collisions in Direction, at the bottom of this script. Now let's move the If Solid is greater than 0 block out of here, back to the new Define Move Sprite X and Y blocks. We can duplicate it so that it is in both. Now we can simplify this because the Move Sprite X only ever wants to set speed X to 0. And vice versa in the Move Sprite Y. Good, that makes things cleaner. Okay, so before setting speed Y to 0, we can now check if speed y is less than 0. This will happen only when the player has fallen down such that their feet have touched the ground. And then we can set the falling variable to 0. Let's give that a quick test. What we see is that the falling variable is always 0 while I'm standing on the ground. But as soon as I leave the ground, the number begins to increase. Now let's look at the define handle keys jump script. I'm going to move the change speed y and the scripts following it up to the top of this custom block, as it will make things a little easier going forward. Within the key press condition, by adding an if falling is less than 2 around the set speed y, we are able to limit Mario to only jump when they last touch the ground in the last 2 frames of the game. Let's test this. Well, that surely stopped him from getting very high. So why did we use falling less than 2 rather than falling equals 0? The reason is that you want to give the player a little room for error, like when they are jumping from the edge of a platform, and also to allow them to jump when skipping down surfaces that mean that they are not always touching it consistently. Now, we want to allow the player to jump higher when they hold down the up key. Make a new variable named jumping for this sprite only. And we'll change jumping by 1 here to keep account of how long he's been jumping this time. The end of a jump is when the player releases the jump key, so we need to switch the if on the key press block for an if-else block. Now we can put the set jumping to 0 here, signifying the jump is over. Now back to the main jump script. Add in an OR and the check for jumping being greater than 0. This is saying we can jump when we are touching the ground or we have already started a jump. But we don't want to be able to jump forever again. So we add an if around the set speed y and ensure that jumping is less than 11. Okay, great. Just change the set speed y to be 13 instead of 14. This is a nice size for a Mario jump. Time to test this baby out. It may look a little odd now without any animation to back up Mario's huge jump height, but this is working really well. We are able to do little jumps, and our big jumps are consistent with the official Mario jump height of 5 blocks high. Wonderful. Now there's one problem that I can see here, and that is that Mario is tending to stick to the ceiling just a little bit when the player is holding the up key. But I know exactly where to fix this. Locate the define move sprite y script and switch the if speed y to be an if else block. The if is now for feet collisions, the else for head collisions. So set jumping to 99 in there, so that when we hit our head, the jumping code is told that we've been jumping for long enough. Quick test, and yep, that did the job perfectly. My head is no longer at all sticky feeling. Okay, it's good practice to ensure we reset these new variables in the reset script. Add a set jumped to 99 and a set falling to 99 too. Alrighty then, it's about time we did a little sprite animation, don't you think? Locate the when I receive move player hat block and where we are positioning the player sprite. You won't be surprised when I tell you to make a new custom block and we'll name paint sprite. Run without screen refresh, and the go-to block can be moved in there. Don't forget to add the paint sprite block back under the move camera block so that it gets run. I'll just move it down here so we have some more space to work. We can check for when falling is greater than 1. This indicates the player is not touching the ground. So we'll switch costumes to the Mario jump costume, and then add a stop this script. I like to use these stop script blocks when we intend to have lots of if conditions. This prevents long build-up of nested if-elses. You know what I mean? Now under this if, switch the costume back to Mario Walk 1, and let's give it a test. Wow, doesn't a bit of animation just bring things to life? I'm loving it already. Now, to be true to Mario, he should not actually keep his hand up once he begins to fall back to the ground. We can code this too simply by introducing an if-else block around the switch costume to Mario jump, and checking for speed y being greater than 0. This is true when the player is travelling upwards, Otherwise, set the costume to Mario Walk 3. That costume has Mario in the same pose as the jump, but his hand is down. A quick run of the project, and that's exactly what we wanted. So with jumping sorted, let's hide the falling and jumping variable reporters to clean up our stage, and we'll move on. Next up, we'll take another look at our player walking scripts that we created in the Define Handle Keys Left-Right custom block. I'll move the scripts into a clean space so we have room to work on the scripts further. Now, firstly, let's get Mario turning to face the left or right. Just add an if-else block with a check for key walk equaling 0. So if the player does press a key, then it will be the else part of this if that triggers. So in the else, drop in a point in direction block, and we'll set it to be 90 multiplied by key walk, which will result in either minus 90 for left or 90 for right. We can give it a quick test to confirm that works. Oh wow, finally! A breath of fresh air to see him finally facing left. Now, let's revisit the Define Handle Keys Left-Right script. This simple code for walking smoothly left and right is the same method I use in most of my games. However, Mario games tend to work a little differently. We need a slower and more steady build-up and change of speed. We'll start by splitting up the acceleration from the deceleration so we can handle them differently. Just duplicate the set speed script into each side of the if-else like this. We'll begin by getting the acceleration scripts right. First, we'll cap Mario's top speed. Bring in an if key walk multiplied by speed x is less than 10. That will be the top speed. And within this, if we change speed x by key walk multiplied by 0.4. Okay, so remember, key walk is -1 when we're holding left, and 1 when we're holding right. So this change of speed will accelerate us in the correct direction. The if above also uses this variable to negate our speed check, to also check for negative speeds. A bit of a clever mathematical hack. Let's run the project and make sure that it is behaving okay. I'll just find some free space to check my acceleration is feeling good. Yep, that's much better. It now takes a bit more time to get to full speed. Okay, now let's address Mario slowing down. I'll just code this logically. So add with me an if-else block, checking for speed x being greater than 0.4. If so, then we change it by minus 0.4. Otherwise, duplicate the if and swap the greater than for a less than. Now we can check for a speed x being less than negative 0.4. Make sure to remember that negative sign there. If so, we change speed x by positive 0.4. And if neither of these conditions are true, then well, we simply need to set speed x to 0 because we are coming to a complete stop. It's testing time again, getting into some free space. Oh yes, Mario is certainly now taking his time to slow down. Great. But here's another Mario trait. When you are actively changing direction, Mario then slides less. So back down to the acceleration script and add in an if-else around the change speed x. We can duplicate the condition above into the if, but we'll change the value we are comparing to 0. Now duplicate the change speed x2 into the else. So this check for speed being less than 0 is true when the player is currently travelling in the opposite direction to the way the player is pressing. That is, a slide. So in this case, we can change up his acceleration to 0.8, making him turn around much faster. Let's have a quick test to confirm. Yeah, cool. It no longer feels like I'm slipping around all over the place, and I have much more control again. Okay, before we add in the walking animations, there's one more platforming dynamic that Mario has that I often miss in my own games. When you aren't pressing left or right, Mario slows down, but only when he's touching the floor. When he's jumping or just in the air, he doesn't naturally slow down at all. This is easy for us to code. We just place an if around the whole of the deceleration script. And as always, checking falling being less than 2, so that the slowing down code is not even run unless we are touching the ground. Now that feels awesome. I think I added too many of those gold blocks though. They're getting in the way of my testing. But Mario is now travelling through the air without me pressing left or right to keep him going, just as he should. So with all Mario's controls working correctly, we can finally add in his animations too. Make a new variable, player frame, for this sprite only. This will be our animation frame for the walk cycle, and make a second variable we'll call temp for this sprite only. Set player frame to 0 after we set speed x to 0. That is when the player comes to a stop. And now we'll add in scripts to increase the frame to show a nice animation. We want the animation to get faster and slower depending on Mario's walk speed. Set temp to the absolute value of speed x, all divided by 19. This means temp will always be positive when we are walking left or right. Now we want to make sure that the animation is never played too slowly that it looks weird. So check for temp being less than 0.2. And if it is, then set it back to 0.2. Finally, we now change our player frame by temp. Now locate the define paint sprite custom block and place an add operator into the final switch costume block. We'll start the costume at costume 1. If we check our player's costumes, then you can see the walk cycle goes from frame 1, 2, 3 and 4 before we hit the player turning costume. So 4 costumes. For this we use a mod operator. On the left side we use the floor of player frame. This is to round the frame down to the nearest whole number. And then mod it by 4 to ensure it loops around and around the 4 costumes only. And oh yes, look at this beautiful thing. It's like we flicked a switch and suddenly Mario's movements make sense. Notice that as he slows down now, his walk cycle also slows with him. This means he no longer looks like he's sliding to a stop, but instead that he is naturally slowing down his walk. It makes all the difference. Is there anything we could add to make this any better? Well actually, yes. Remember that player turning costume? We can use this to give Mario an awesome turning animation. For this, we need a new variable, player action, for this sprite only. This will keep track of the special actions the player is currently performing. Still in the paint sprite script, we'll check if player action equals turn. And if it does, we'll switch costumes to Mario turn, and then stop this script. The best place for this is just before the walking animation script. Okay, nice and simple. We just need to set this variable to the value turn, and this will activate the animation. So locate the handle keys left and right custom block, and we'll set player action to walk at the top here for now. Then scroll down to the turn around code here, and we can simply set player action to turn, just like we said. I'll run the project, and we can check out his new turning animation. Oh, it works! Loving it! This is getting so beautiful, we really must fix Mario's width. He is still able to get far too close to blocks, and falls off ledges that he should be able to stand on. Locate the reset player script. Add a new variable named width for this sprite only. Set it to 8 and place it next to the set height. Now I'm going to also fix another potential bug here that might crop up later by making another variable named minus tiny, that is hyphen tiny. Make it for all sprites this time, all sprites. And set it to, now do this carefully, negative 0.0000001. Did you get that? Negative 0. And then 5 zeros and finally a 1. Yep, that really is a very small negative number. Now let me show you what this is for. find with me the define fix collision at point script. Now see those negative 0.01 numbers? So these were my previous negative tiny numbers, but it just so happens that they are not really tiny enough once we start adding in slopes and the like later on. So I'm fixing that now. Replace both the negative 0.01 values with the new negative tiny variable. OK, to give Mario some width, scroll up to the define fix collision in direction script, and we'll duplicate the 3 collision checks. At present, we are just looking for 3 central points at his feet, head, and middle. Now we'll widen the checks by first checking it to Mario's left by subtracting width from x. And then on the right by adding to x, width, and minus tiny. OK, so put that all back together and we can see if that worked as expected. My gosh, I hope you've got this far in your scripts too, because this is just too fun. Mario suddenly feels a lot more solid. I can edge nicely over the edge of platforms without dropping off too early, and I can no longer get up too close to walls. Very nice indeed. Let's hide all these variable reporters since it's all working so well. Now, as a special treat in the closing few minutes of this episode, I just wanted to try to sneak in some smoke particles for when Mario changes direction. They will really finish off the whole Mario look. Hopefully you've brought in the particle sprite from my resource project, so click into that sprite now. So working quickly with me, let's add a when flag clicked. We need a frame variable for this sprite only that will set to the blank value. We'll use this to identify that the sprite is not a clone in a moment. As always with this pixel art tileset, we'll size to 200% and then hide. Now bring in a when I start as clone, and then set frame to 1. That will distinguish the clone. Make 2 new variables named x for this sprite only and y for this sprite only. These hold the position of the dust cloud clone. Now when this cloud particle is created, we want its position to be the same as the player's position, so bring in a setX2 block. However, the x variable of the player sprite was defined as for this sprite only, so to access it, we need to use the thing block in the sensing category, and change the of to Mario, and then we can change the left hand side to the x variable. Be careful not to select the x position, as that would be the wrong one. We need to do the same now for the y variable. Now we need to use the x and y to position the sprite clone on the screen using a when I receive position tiles hat block. The goto xy follows our usual pattern of x minus camera x and y minus camera y, and then we make sure to show the sprite. And before we forget, we need to ensure this position tiles event does not run for the original sprite that was not a clone by adding in an if frame equals empty value. Then stop this script. Right, so all this code, but nothing is creating the smoke particle clones. Click on the Mario player sprite and locate the define handle keys left-right script. Find where we are setting the player action to turn, and this is where we want to generate our smoke. We'll make a new custom block for this named Make Skid Smoke. Run without screen refresh. And we'll call it right here after setting player action to turn. Now in the Make Skid Smoke, simply create clone of particles. Let's run the project and see what it does. Well, that's weird, but it's also correct. We are creating smoke sprites at our location every time we turn quickly. Now back in the particle sprite, we'll move the particles down to be under Mario's feet by subtracting 20. That's a little better. If you look inside the smoke particle costumes, you can see that there are 2 sizes for us to animate over. we will use a frame variable to handle this, as we did for the player's walk cycle. Bring in a change frame by 0.4. The animation is only 2 frames long, so if frame is no longer less than 3, we can delete this clone. And to handle the change in costume, we switch costume to the floor of frame. Testing the project now has this looking a lot better. The smoke is well positioned and only lasts for a short time. The only problem I can see is that there is simply too much of it. Switch back to the Mario player sprite and we'll limit the amount of clones that get created. Firstly, change player frame by 1. And then add an if around the create clone that checks for the player frame mod 3 being less than 1. That will only happen 1 in every 3 frames. Testing that now, and I hope you'll agree that that makes the smoke cloud look far more convincing. Oh no, wait, look! When Mario jumps, he's leaving smoke trails in the sky. How did we miss that? Scroll up to the call to make skid smoke. Oh man, did I call it make skip smoke? That was a typo. Sorry. Anyhow, bring out an if block and surround the whole set player turn and make smoke blocks. The condition to add is a check for falling being less than 2, yet again. So no turning animation when we are in the air. Yes, that did it. Wonderful. And I think, my friends, we are there. Although I may have overdone it with the number of golden blocks in my way. I'm just going to go to the generate sprite and change the pick random to be 1 in 25 rather than 1 in 10. Wow, what an epic scripting journey that has been. I was thinking this would be a quick tutorial so that we could move on to other more exciting things like off-screen enemies, the level designer or sloping tiles, but I'm really pleased we spent the time to get the platforming scripts right. Plus, the added player animation makes a huge difference in how the game feels when you play it. If you have managed to keep up and everything is working, then I think you're going to be pretty pleased with yourselves. And rightly so. This level of player animation is not often seen in a Scratch project, so your projects are going to look pretty special. Why not leave me a comment under the video to let me know how you got on? If you enjoyed this tutorial, then please smash that like button. Don't forget to subscribe to the channel to avoid missing my next exciting video. We are really making progress on this project and I can't wait to continue the journey with you. And I'm pretty sure we will be looking at creating a level designer next. But until then, Scratch on, guys.